Light affects our lives in many ways. These fireworks illuminate the sky with many brilliant colors. This vibrant flower attracts insects such as these bees. We use cell phones to communicate with family and friends. We get our teeth x-rayed to identify spots of decay. We use microwave ovens to warm food. And we warm ourselves in the rays of the sun. What do all these examples have in common? They're examples of the different kinds of light in action. During the next few minutes, we're going to explore the many different kinds of light and explore the many characteristics of light, and take a look at how light affects our daily lives. Light is a form of energy that we detect with our eyes. You decide. What enables you to see the luger coming down the luge course? Is she producing or reflecting light? If you said that she's reflecting light, you're right. The surface of the water behind this bird is reflecting light from the sun. Most things we see outdoors reflect sunlight. The sun is the source of energy that creates daylight. Even the moon reflects the light of the sun. In some cases, objects do not reflect light, but instead they create or produce light energy. This flare produces light via a chemical reaction, while this fire produces light energy from the burning of wood. This glow-in-the-dark stick produces light from a chemical reaction. The light energy we receive from the sun is the result of nuclear reactions. Now that we understand that the light we see is either reflected or created, let's take a closer look at how light is formed. This is a piece of magnesium oxide, a metal that has the potential to burn violently. What creates this bright light? In short, light is created when small particles called electrons change position inside an atom. This is a model of an atom. The small particles orbiting on the outside of this atom are electrons. These electrons contain energy. The amount of energy in a given electron determines its distance from the center of the atom. When an electron absorbs energy, it may jump to a higher energy level in an atom. But when an electron falls to a lower energy level, it gives off energy in the form of light. This packet of light contains electromagnetic energy and is referred to as a photon. The light we see from these fireworks is in the form of electromagnetic energy. We're surrounded by a sea of electromagnetic waves. For example, this radio is receiving radio waves through the surrounding air from distant radio towers. And we're bombarded by ultraviolet waves from the sun. The sun emits a wide range of different types of electromagnetic waves, referred to as the electromagnetic spectrum. An electromagnetic wave is the result of alternating electric and magnetic fields. These fields are perpendicular to each other and are positioned at right angles to the direction of the wave. Electromagnetic waves are also called transverse waves, meaning that the energy particles inside the wave move at right angles to the direction in which the waves are heading. Certain other types of waves, such as sound waves, blasted from this speaker, can cause matter, such as the water in this cup, to vibrate. Electromagnetic waves, such as this laser, do not necessarily cause matter to vibrate. Electromagnetic waves do not need a medium through which to travel, and can therefore travel through space where there is no matter. Because of this, light from stars and other forms of electromagnetic energy travel easily through space. In the late 1600s, Isaac Newton developed the first explanation for the behavior of light. He stated that light behaves as a stream of tiny particles. Other scientists disagreed, stating that light travels in waves. They based their theory on the findings that light beams can bend around objects and can pass through each other. These behaviors are unique characteristics of waves. This was the dominant view of the behavior of waves for many years. Over 100 years later, Albert Einstein, the great physicist, reopened the debate. He stated that light is made up of tiny energy packets called photons. Scientists now generally agree that light can behave both as waves and as photons. When light travels, it acts like a wave. But when light is reflected or absorbed by objects, it behaves like energy particles. You decide. What's the difference between these two lights? That's right. The light on the left is brighter. You also may have said that the light on the left is closer than the light on the right. This is also true. Light intensity, or brightness, varies with the distance from the light. This can of spray paint helps to illustrate the concept. Notice the intense area of paint that is produced when the can is held close to the paper. But when the can is held further away from the paper, notice how the color is less intense. Similar to the paint, the intensity of light decreases with distance. While the intensity of light varies with the distance from the light source, the speed of light varies according to the medium through which it passes. In space, light moves at a rate of nearly 300,000 kilometers per second. This is remarkably fast. The light from our sun, which is approximately 150 million kilometers from Earth, takes only 8 minutes to reach the Earth. In other mediums, such as water and glass, the speed of light decreases by nearly 30%. When discussing large distances in space, we use a unit of measurement called the light year. A light year is the amount of distance light travels in 1 year. This distance is 9.46 trillion kilometers. This star, for example, called Eta Carinae, is over 7,500 light years from Earth. This means that much of the light we see from stars is hundreds or thousands of years old, originating long before we were born. You decide. What makes this candle light different from this laser light? The answer lies in their wavelength. The laser light has a shorter wavelength than the light from the candle's flame. What is wavelength? Wavelength is the distance between a point on one wave and the same point on the next wave. The wavelength of the orange wave is longer than the wavelength of the green wave. Another term used to describe waves is frequency. Frequency is the number of wavelengths that pass a point each second. This orange wave has a low frequency, while this green wave has a high frequency. Generally speaking, waves with short wavelengths have high frequencies, and waves with long wavelengths have low frequencies. These are important concepts in helping us to understand the electromagnetic spectrum. decide. What makes this microwave different from this oven? While both are used to heat food, they utilize different kinds of electromagnetic waves. There are a wide variety of electromagnetic waves, only a small portion of which can be seen by the naked eye. The rest are invisible. The electromagnetic spectrum classifies electromagnetic waves according to their wavelength and frequency. This is a diagram of the electromagnetic spectrum. Notice how the waves on the left have a long wavelength and a low frequency, while the waves on the right have a short wavelength and high frequency. On the far left side of the electromagnetic spectrum are radio waves, which have a long wavelength and low frequency. And on the far right are gamma rays, which have a short wavelength and high frequency. These waves possess a great deal of energy and can be dangerous. The other types of electromagnetic waves are found on the spectrum between radio waves and gamma waves. This radio is trying to lock in a signal that is transmitted from this radio tower hundreds of miles away. The tower is sending out radio waves. Radio waves have long wavelengths and low frequencies and are therefore found on the left side of the spectrum. Radio waves are extremely useful. They're used in airport radar to track airplanes and to guide them safely to their destination. Radio waves are used to transmit signals from satellites far above Earth to satellite dishes. Television sets that are not connected to cable but rely on antennas use radio waves to produce the picture and sound of a TV program. High-frequency radio waves, called microwaves, enable microwave ovens to cook food. This colorful picture shows differences in temperature in the Earth's oceans. Red indicates the warmest areas, and blue indicates the coolest areas. Infrared rays are also used in remote control devices, such as this one. Infrared rays have a wavelength that is slightly longer than visible light. You can detect infrared light when you feel heat. Infrared radiation produces heat by causing the molecules in an object to vibrate more quickly, causing the temperature to rise. Nearly half of the rays emitted by the sun are infrared rays. Special infrared cameras take pictures of infrared radiation emitted by objects, such as this building. The areas of heat loss are indicated by the colors red, white, and yellow. They allow a carpenter or an electrician to determine where insulation is needed. Located toward the center of the electromagnetic spectrum is visible light. Visible light is light we can see and consists of the colors red, orange, yellow, green, blue, indigo, and violet. Red has a lowest frequency of visible light, while violet has the highest. The visible spectrum is essential to life on Earth, with nearly half of the energy emitted by the sun in the visible range. This device, called a prism, refracts the different wavelengths found in the white light of the sun, causing the light to separate into individual colors of the rainbow. It's interesting to note, however, that visible light only represents a small portion of the entire spectrum. You decide. What types of rays are the cause of painful red sunburn? Ultraviolet rays emitted by the sun pack a great deal of energy and can burn exposed human flesh. That's why it's a good idea to cover up with hats, sunglasses, and sunscreen if you plan to be outdoors. X-rays are another part of the electromagnetic spectrum that are even more powerful and energetic. Perhaps you've had an X-ray taken of your teeth or another part of your body. X-rays have a high frequency. Bones absorb the X-rays, but soft tissue allows X-rays to pass right through, exposing special film to create an X-ray picture. Stars are believed to give off a great amount of X-rays when they explode. Waves with the shortest wavelength and highest frequency are gamma rays. These rays have the highest energy and therefore possess tremendous penetrating ability. Prolonged exposure to gamma rays can cause severe illness. During the past few minutes, we've explored some of the basic principles of light, beginning with the creation of light. We took a close look at how light can behave like a wave or like energy particles. We studied the intensity and speed of light and took an in-depth look at the different types and characteristics of waves that make up the electromagnetic spectrum, including radio waves, infrared waves, visible light, ultraviolet waves, X-rays, and gamma rays. So, the next time you use a microwave, turn on a light, or use a cell phone, think about the different characteristics of light. You just might think about light a little differently. Fill in the correct word when you hear this tone. Good luck, and let's get started. Number 1. A photon contains energy. Number 2. Light is transmitted by both small particles and by Number 3. The intensity of light when distance increases. Number 4. Distances in space are measured using units called Number 5. Waves with longer wavelengths have frequencies. Number 6 is the number of wavelengths that pass a point each second. Number 7. Rays have the shortest wavelength and can be very harmful. Number 8. The types of electromagnetic waves that allow us to talk on cell phones are waves. Number 9. Light is located toward the center of the electromagnetic spectrum. And number 10. Waves can cause sunburn.